we now have our principal to be 20,000 and our rate to be 2. Now let's see what we are going to have. 30 will cancel 30, right? 5 here will 5 in 20, I think 4. Right. 4 here will 5, 4 in 100. That is 4 in 22, 10, 2. Remains in 25. Yes, in 25. 2 here 1. Oh, sorry, to be, you can divide them. 2, 2 into 1, 25. I'm done. That is 2. So it will remain 1. So we add a 0 to it and got this point, and that is what 5. So is what does this mean? It means 12 and a half year. It means was 12 and half year. So we got 12.5 years. That's we yield. So we are going we we are moving to JSS3. JSS3. So JSS3, we said third week also. Third week. But we have done the fourth and the fifth week under addition and subtraction of binary. I think under that I remember something, but let's first, the topic of today will be expansion. Expansion and expansion and expansion and the topic is actually expression involving bracket and fraction. Expression involving bracket and fraction. So but what we know, this form of this thing too is expansion. So we got the first part of it as expansion. But let me recall something. Under that binary, I want to recall a situation whereby GS3 is given this. Right, given 1 to base n is equal to 1 to 1 base 3. So, and you are asked, they say find n. So, this one is base n, base 3. So, what to do is that bring the 2 to base 10, then they will be equal. So, what will I do? 1 to base n is equals to 1 to 1 base 3. So, what we normally do, this will be 3, 3, 3. Power 0, power 1, power 2. Multiplication, multiplication, multiplication. Then addition will be in between. Here, it will be n, n, because n is the base. Multiplication, multiplication, addition will be in between. So power 0, power 1. Now let's move on. This will now be 1 times n raised to power 1 plus 2 times n raised to power 0. It will now be equal to 1 times 3 raised to power 2, add to 2 times 3 raised to power 1, add to 1 times 3 raised to power 0. So this one will give me n plus, this will be 1. 1 times 2 will give me 2. So to be equal to 2 raised to power, 3 raised to power 2 is 9. 9 times 1, 9. And this one will be 6. And this one will usually be 1. So n plus 2 9 is equals to, this is 10, 16. So when you get to this stage, we collect the like terms. Collect the like terms. So this is number, go and meet number. So if this one will turn to minus, minus 2, n will be equals to 14. So this is just, so in case You see something like this. So let's move to expansion. Expansion is divided into two. We have single expansion and we have double. But let's first start with the single. Now, because one step one leads to another. Let's say I have 2x plus 2. So this bracket here signifies multiplication. So what I do is that this multiplied by this plus the same this one multiplied by this. This will now be 2 times x plus 2 times 2. And 2 times x will give me 2x plus 4. So that will be my answer. I have successfully expanded it. But what I do for JSS3 is that immediately after this topic, I come in with factorization. Immediately. Why am I doing that? Because I know that expansion is opposite of factorization. So let me say factorization. I like instant linkage. So given this 2x plus 4 and I asked to factorize. If you ask to factorize this, simply you ask to return it into the brackets. Simple. So what you do is that 2x plus 4, you look at the 2, what is common to both of them? And we 2 can divide this and 2 can divide this. So I bring that 2 out. I open the brackets. Then, okay, let me do it forward. I bring the 2 out, I open the bracket. Now I use this 2 to divide this. 2x divided by 2. So it will remain x. I write it inside. I use the same 2 to divide this. 4 divided by 2. That's 2. So you see that the thing returns back to this. So through factorization, you bring it back to bracket. When you expand it, you bring it to factorization form. So let's still do another single. We have 3p, open bracket, p plus 3. 3p. So all this one now multiplied by this plus all this multiplied by this. So this will give us 3p multiplied by p plus the same 3p multiplied by 3. So this will give us, now this is multiplication. If it is addition, 3p plus p plus 1p, it will give us 4p. That's addition. But this is multiplication. When you are multiplying a times a, it gives me a raised to power 2. So this one will be 3, p raised to power 2. Now p squared. Plus this multiplied by this will give me 9. Then p. So this is the expansion. But if I'm asked to factorize, this, let's say 3p squared plus 9p. So what I do is that what is common? In the number 3 is common. I can see 3 there. And p is also common. So I write 3p. And I use the first one to divide by this. 3p divided by 3p squared divided by p. This 3 cancel this. 1p cancel 1p. It remains 1p. Then 9p divided by the same 3p. p cancel p, here 3. So this one has successfully come back to the beginning. So I could use any of it. Now let's go to double expansion. We have double expansion. Now double expansion is not something that is hard, but it's just that now check this 1 plus x, another bracket 1 minus x. So you have to expand this now 2 brackets. I'll now turn it to single. How do I make it single? This one multiplied by the whole bracket plus this multiplied by the whole bracket. Don't forget the symbol, the sign. Very, very important. 1 multiplied by this bracket, 1 minus x, plus x multiplied by this 1 minus x. You realize at this juncture that you have successfully brought it back to single expansion. So I can now expand like we normally do. This times this, that say this times this, and this times this. This times this will give me 1. 1 times this, the minus is here. 1 times this, it will give me x. 1 times any number is that number. Now, plus x times 1, it will give me plus x. Now, there's multiplication here. Minus times plus, very, very important, especially at the end. Minus times plus could be at the beginning too. Minus times, it will give me minus, plus times minus is minus. X times, say, like we said, that x squared. Now, you could do something further here. Because 1 minus x plus x, this one they have the same variable. So I can add or subtract. So this is 1x, 1x. But this is minus and plus. We say minus 1 plus 1. So I borrow 1, I have 1. I'll be having nothing there. So this one will just cancel this, m minus x squared. So by second or third time, you still do a second time difference of 2 squares. So you'll be knowing this one better. Now number 2, let me do one more. Minus 5. Okay, sorry. Let's start like this. Minus 5 plus p into bracket 3 minus p. So if I'm asked to expand this, how do I go about the expansion? I said I'll take it 1 1. I'll take minus 5 to this, the whole of this bracket. Then I'll take this one plus p next. Plus p to the whole of the same bracket. So let me continue. Minus 5 times 3 is going to give me minus, because this one has invisible plus here. Minus times plus is minus. 5 times this to be 15. Now minus times minus here, plus 5 times p is 5p. Fed p times 3, they are both plus plus, so to give me 3p. So minus times plus is minus, p times p squared. So this will go. So I could do something manipulation on, because this 5p, 3p. So if I add them together, it now be minus 15. This one give me plus 8p minus p squared. So let's just stop here before we start quadratic equation. So let's go to the second part of it. Let's go to the second part of it. Let's look at the fraction part involving fraction. When there is fraction of this stuff and there are something in brackets, I've told you fraction, addition and subtraction, you look for the LCM. So the LCM of this, like I said that time, you look at it, the two. You could do it in normal way of LCM, fine. And you could make it like, can one of them divide the other one without knowing that? Yes, 7 can divide it, so I'll take the bigger one. Since I know that one of them can divide another. How many 7 in 14? 2. I use it to multiply the whole of the bracket. So it will be 2 into bracket a plus 1. So my addition goes here. 1 times 14 in 14, 1 times the whole bracket. So this one will be equal to I can now expand. You look at this one is now single expansion. Also, this one is single expansion. So 2 times a gives me 2a plus 2 times 1, 2. You are through with that. Plus 1 times 3a, it will remain the same thing, plus 3a. Plus times minus, minus 1 times 2, 2. All over 14. Now, 3a plus 2a, it will give me 5a, because it's addition. 2 minus 2, and I told you when they're having different signs and they're the same thing, they will cancel themselves out. I am going to, I have 2 all over 14. Of course, this is with variable, this without variable. If they can divide, you divide them. But if they cannot, you leave it in this. So, till I come your way next time, you have questions regarding all